Hey guys, this is chapter 3 of your science. Now, this should be the last of the questions that you have. That being said, I need you to turn your questions in on Wednesday to get credit for them. But then again, on Wednesday, when you turn yours in, I'm going to post the answer sheets so you can have them to study for the test on Friday. Now, because there's several units in this section, I'm going to do like half and half instead of doing it all at one time. So you'll have kind of like a mini test over chapters 1 through 3 this week, but you are required to turn in your study guides. And then Wednesday afternoon, I will post the answer documents and a study guide to help you. And then on Friday, you'll have your science test. Now, your science test will be kind of like a multiple choice quiz, matching, and then you will have a writing activity. And your writing activity is going to be from one of the big questions from the 3 chapters. So actually, you could go ahead and look at the 3 big questions and start coming up with some ideas. But what's important, vocabulary, just understanding what we read, and it's nothing to get stressed over. So you'll have plenty of time to study this week for it. And that's it. So let's get started. We're going to be on chapter 3, earthquakes. On the top floor of an office building, workers suddenly feel shaking. The shaking lasts a few seconds and then stops. The workers ask themselves, what was that? And I totally forgot to say the big question for the chapter. Here's the big question. Why are some communities more likely to experience an earthquake than others? Why are some communities more likely to experience an earthquake than others? All right. 100 miles away, a gardener finds himself on the ground. The tremor had been strong enough to knock him down. He even saw his lawn roll like waves. He looks over at the road and sees a large crack or large cracks. All of these effects are results of an earthquake. Sudden shaking of the ground that usually occurs at or near a place where the plates of the earth crust meet. Communities near these sites are more likely to experience earthquakes than other communities, or than communities far away. So, an earthquake, by definition, is shaking of the ground caused by seismic waves. Shaking of the ground caused by seismic waves. Now, if we look at the image on page 13 on the screen, you can see that the caption says an earthquake can shake, roll, or shatter things on the Earth's surface. So, where this road was, the earthquake caused it to actually crack open. So, that's how strong it was. Moving plates cause earthquakes. Plate movement cause earthquakes. When the plates push against each other, pressure builds up. Over time, one plate can suddenly slip over, under, or alongside the other plate. These interactions can involve so much friction that the plate's edges that are in contact become stuck. While the plates keep moving, the edges buckle and bend. The rocks store up an immense amount of energy required to push the plates. Stress builds up in them. Eventually, the stress is too much for the plates to bear, and then suddenly they move. One or both plate edges may move several or even dozens of meters in the span of seconds. The energy wave that are released are known as seismic waves. So let's look at this image. Now, before the earthquake, the ground is flat, the road is intact, and the power lines are tight. So that's your first image right here. Now, as the seismic waves move through the earth, now remember the seismic waves are the after effects of the plate movement. The ground can move in different ways. The ground can, one, expand and contract in the same way directions as a wave, move up and down, move back and forth across the direction of the wave, or they can move in a circular motion. So, right here, this is the direction that the seismic wave is moving. Up here, you have what the reaction is. You can see the road is moving. It's kind of like uneven now. The power lines have been turned. Now, notice the type of damage caused when the ground moves back and forth across the directions of the waves. We have cracks, and then the power lines are down. This is circular motion. This is when the waves move back and forth. So it seems like the ones with the circular motion can cause the most damage. The map here shows the locations of nearly 1,000 earthquakes. Notice how the circles that mark the earthquakes are mostly along a gray line. The gray lines mark boundaries between plates. Earthquakes along these boundaries are caused by plate movement. People who live near these areas experience more earthquakes than people who live elsewhere. There is also significant volcanic activity along the plate boundaries. So this is what we call the Ring of Fire. And I told y'all that a few weeks ago. Now, in which area would people experience the effects of earthquakes? So mostly the people who live in and around the Pacific Ocean right here. Which area would have earthquakes would be not immediately impact people? Well, you have like the eastern United States over here, places over in this area. But just because they're not in this area doesn't mean that they're not, or they can't be impacted by an earthquake. Earthquakes can happen anywhere. Now, here is a more like immediate thing. You can actually find this. I found it interesting when I located it. But this is actually the USGS, the United States Geological Survey, and they keep up with earthquakes. And what you see here, these red lines are plate boundaries. And you have these dots that represent earthquakes. And you can even, this website, zoom in. Watch it not work. Okay. Let's go to the United States. That's what we know best. All right, right here. Now, as you can see in the United States, if you, like we do live in the United States, most of the people that are affected by earthquakes live in the area west because we have our plate boundary here. But there's also things called fault lines, which can... where'd they go? I know they're here somewhere. They changed the websites and stuff in here. Time zone. Settings. There was a thing where you could pick fault lines. Oh, here it is. Okay. So we have fault lines, U.S. fault lines. This is also where earthquakes are likely to happen because a fault is kind of like a crack in the Earth's surface. And as you can see, it's mostly in the area in the west. Now, one of the reasons this could be, and if you look right here, this is mostly where the Rocky Mountains are. And the Rocky Mountains were formed through, the Earth pushing up. So you have a lot of fault lines that are over in this region right here. But like I said, that does not mean that nowhere else is not prone to earthquakes, but they're just more likely. And here is that same image, the ring of fire right here. Goes around here. Okay, let's go back. Okay. Surface effects of earthquakes. How an earthquake affects Earth's surface depends on the size of the seismic waves. What the ground is made of and what is on the surface. In some places, the ground can be made up of loose or water-saturated soil. When seismic waves pass through it during an earthquake, anything that is in or on top of the soil can sink or topple over. Firmer ground shakes less, but it can move up and down relative to its original position. This can cause a lot of damage to any structures built over the area. So if you look right here, this picture, it says when a powerful earthquake struck San Francisco area in 1989, much of the worst damage occurred in areas as the Marina District, which is built on loose soil. If I'm not mistaken, if this is the earthquake that happened like during the baseball game was going on, I think I'll have to look. Okay, earthquakes can also loosen rocks and sediment from slopes. When this happens, landslides can occur. Landslides can damage or destroy both natural and human-made structures. Communities where there are many hills or mountains and where let me start all over again. Communities where there are many hills or mountains and where it rains a lot are more likely to experience landslides than communities where the land is flat. Now, landslides usually happen in areas that has, of course, mountains, because whereas we, like in our area, we're mostly flat. We don't have a lot of hills or mountains. But what is the mountain itself is like compacted soil, and if it gets kind of loosened, it can give way. So that's where a lot of your landslides occur. Now, measuring and detecting earthquakes. Earthquakes are detected and measured by tools called seismographs. These tools are also known as seismometers. Convert the vibration caused by seismic waves into lines look like a graph. The greater the peaks, the stronger the earthquake. Seismic waves can travel across Earth's surface and through Earth's mantle and crust. The seismometers can detect earthquakes that are thousands of miles away. Seismologists study the readings of the seismograph and work together to help communities prepare for danger in their area. Now, seismologists, they are the people who study earthquakes and volcanoes and stuff like that. Geologists measure earthquake strength on a scale of magnitude. The scale is based on how much energy the earthquake releases and the size of the seismic waves. A magnitude 3 earthquake generates waves 10 times larger than the magnitude 2 earthquake. Is it the Fuji scale? Oh, that might be a tornado, but anyway. So here is a seismograph. Now it is positioned on the Earth's crust. And what happens is when the parts of the Earth moves, this pin right here, it's kind of like dangling, it moves back and forth to record the vibrations. Now this seismogram, which was created by Seismograph, is from the devastating 2011 earthquake that struck Japan, that caused a huge tsunami that occurred afterwards. Living with earthquakes. In Japan, earthquakes are common. They have caused much damage. The construction industry there has developed new designs to make buildings more resistant to seismic waves. There are many criteria and constraints the industry had to consider. Criteria are the things the solution must do or have. Constraints are the things that limit the possible solutions. Having alarm systems that provide notice of an earthquake before its waves strike is one way of coping with earthquakes. Another is to avoid buildings in areas where the ground is vulnerable to landslides. When an earthquake occurs, you should take shelter under a table or desk. If there are neither of these, take shelter along the interior wall. Remain on your knees and bend over. If possible, cover your head, neck, and back. If possible, hold on to something sturdy until the shaking stops. Now, buildings, they have developed, like in places like California also, they have created buildings that can resist earthquakes if they are made of strong material that vibrate without breaking. Braces can transmit the vibrations more evenly throughout the building. Small structures at the building's base can wobble and roll without transferring much motion to the rest of the building. So basically, what that means is in areas like in Japan or in California, these buildings must reach certain codes. And those codes, some of them are you have to have a earthquake resistant building that can withstand the shaking and the vibration. Now that is all for the earthquakes. If you need to, I suggest that you read this again to yourself or read it out loud to someone else. And then tomorrow, you're going to work on your last set of questions. And then on Wednesday, you're going to turn just the questions in, not your packet, not the reader, just the answer documents, okay? All right. I hope y'all have a good day. Hope you have a good week. See you later.